Good morning. My name is Mweneni and I'm taking you through the material for 2019. This is for examinations for 2019 and also for your assignments, whatever work, assessment work you have to prepare for this year. Most of the topics covered in those question papers are mostly what is covered on this presentation. Though we cannot cover everything in this period of time, I try to cover as much as possible, especially the topics that are repeating. So those are the ones I'll be emphasizing on, and those are the ones that I'll be spending time on mostly. Others are equally important, it's just because of time. And these are the ones you should concentrate on when you do your studies, but it doesn't mean you should leave out the others completely. I am happy that you took this subject as your choice of subject to teach, as we need more teachers for these subjects. It's a bit of a challenge, but with hard work, I'm sure you will overcome and you'll be a great teacher. So let's start. We'll start with the waves. I'm spending more time on waves as they will be repeatedly asked in your assessment, whether it's in the assignment, whether it's in the examination, in all the examinations. It doesn't mean other topics will not be covered, but over the years, there have been some challenges with the students answering this topic particularly. That's why I want to concentrate on it and highlight some of the things. So we have two types of waves. The first type of wave is a transverse wave. You'll be asked to define a transverse wave, and this is the definition I'm expecting you to give in your own words, of course, that a transverse wave is a wave in which particles of the medium move in the direction that is perpendicular to the direction of the wave motion. And an example of a transverse wave could be waves on a string. Also, water could be transverse waves sometimes. And this is an example. You see, as the wave is moving along, there is a direction that is perpendicular to the wave motion, and this is the direction of the way the energy is moving. And then this is another example of a transverse wave. Sometimes you'll be asked to draw the transverse wave. Sometimes you'll be asked to differentiate or even to define it. Now here in this diagram, notice the motion of each dot relative to propagation of the wave. So you see each dot is like in a straight line, is forming a right angle. That's why we are saying is perpendicular to the wave motion. Now we come to the second type of waves, which is a longitudinal wave. A longitudinal wave, if you are asked to define it, is a wave in which particles of the medium move in a direction parallel to the direction of the wave motion. And these are also called compression waves. An example, or a very good example of a longitudinal wave, is sound waves, because they are always in compression. And here we have a diagram that is showing us a longitudinal wave example. And now here, look at the motion. They are in the same direction. These particles are moving in the same direction as the wave motion. They are in compression. Now let's look at this diagram. It's showing the difference between the two, between the longitudinal waves and the transverse wave. And the two diagrams here explains. One is in the straight line. If you look at the red arrows, for the longitudinal waves. And if you look at the transverse wave, the red arrows, they are in perpendicular to the wave motion. So if you are asked to differentiate between longitudinal waves and transverse wave, you could use these two diagrams to differentiate between the two in your discussion. Here again, we have another example differentiating longitudinal and transverse wave. But some waves, like water waves, they can be described like they can be a longitudinal wave described as a transverse wave. I'm just giving you that. And then here we have other wave types, which are a combination. I talk of the water waves. We have secular, we have electromagnetic waves, which are also transverse waves, and they are not mechanical. Then here we have a diagram of a wave. So if you are asked, you are given a diagram of the wave, sometimes you are asked to draw the diagram of the wave. This is a standard diagram of the wave that will be expected. Let's just label it. We have the two waves that are in equilibrium. We have a crest and we have a trough, and we have an amplitude. We have a wavelength. This is a wavelength. It can be from one trough to one trough, from one crest to one crest, or it can be an S, complete S shape. That gives us a wavelength. And you'll be asked to calculate the speed of a wave. The speed of a wave, like all other speed, is just distance traveled by a wave divided by the total time taken. This you need to know. And then we have a derivation from the wave speed. You can either be requested to calculate the distance or to work out the time given the speed and the distance, or you'll be asked to work out the speed given the distance and the time. Or sometimes you'll be also from the wave speed given the frequency, then you can use that instead of to derive the time and then do your calculations, and vice versa also. You can be asked given the other variables, and then you can be asked to work out the frequency. So from the wave speed, you can work out four things: either the distance, the speed, the time, and the frequency. Okay, here is the wave speed. This is how we write it correctly, and we don't have we don't have a worked out example. Okay, here let's do this together as an example. We can work it out together. It says determine, you are given the graph of a wave, and it says determine the amplitude, the wavelength, the frequency, and the period. So what is the amplitude? Here we can see from the diagram, the amplitude is 3.5 meters. We are given here the wave speed, which is 20 meters per second. And then we have here, from one point to another point, we are given a distance of 8 meters. We can use this one to work out the wavelength. And then we can use the speed and this distance to work out the frequency and the period also. Okay, now we go to other properties of waves. Waves can be reflected, waves can be refracted. So let's look at the reflection of the waves. Reflection of the waves occur when a wave strikes a medium boundary and bounces back into the original medium. Completely reflected waves have the same energy and speed as the original wave. So, for example, the water wave hit a wall and then they bounce back. That is, they are reflected. That is a reflection of the wave. And let's look at these examples. Okay, there is a fixed end reflections. This can be called reflection of a rigid medium. Okay, here you are given an example of this moving diagram. Let's look at it again. You see, it hits, it's moving, then it hits a boundary, then it's reflected back. But look at the direction and the arrow. Now we have an open-end reflection. This can be, let's look at this example. The end is open, so it hits a boundary and then it reflects back. Let's look at another one. Fixed end and the open end. You see the two diagrams that are moving, how the waves are reflected back. Okay. Now we go to refraction. Refraction is a transmission of waves from one medium into another. When they change medium, like they move from air into water, then they change direction. So we say they are refracted because the mediums are no longer the same. The refracted waves may change speed and wavelengths, but they do not change the frequency. You have to take note of that. When waves are refracted, they don't change the frequency. Okay? Is one of the properties of refracted waves. The waves can bend when they pass from one medium into another. This we have already spoke about, the effect of a bending spoon or a pencil. If you put a pencil in water, you will see as if it bends, but it's not broken or it's not bent, it's just straight. It's only that you are looking at it through two mediums, through the water and through the air. Now let's look at the reflection of water waves where they move from deep water to shallow water. They also change direction. Here is a diagram. You see how they change direction from deep water to shallow water, and this is one of the common questions where you'll be asked to complete a diagram. You can be given half a completed diagram, maybe from deep water, and they say complete when it moves into shallow water, or vice versa. We call this bending a diffraction. The diffraction is a bending of a wave around a barrier. Diffraction of waves combined with the interference of diffracted waves causes diffraction patterns, and there are so many and very interesting phenomena. Now we can look here for diffraction. First we look at the one that moves from deep water to shallow water. Now here the water is passing through a slit. There is a narrow barrier in between. We have some water moving in, and then they have to pass through a narrow slit, and then they bend. And then we say they are diffracted. And this is also another example of diffraction. Now we go on to density. Density is something you have been doing since grade 9, I think. And here I just want us to focus on calculations, though you need to look at other, like the definitions and everything. So here we have a question. What is the density in gram per cubic meter of 48 grams of a stone if it raises the level of water in a graduated cylinder from 25 cubic centimeter to 33 cubic centimeter? And you are given choices, and this is a multiple choice question. Is it 0.2 gram per cubic centimeter? Is it 6 gram per cubic centimeter? Or is it 252 gram per cubic centimeter? And here we can see the two diagrams of a cylinder. Before you add the stone, it was 25 cubic centimeter. After adding the stone, it's 33 cubic centimeter. Now let's do this together to determine the density of this stone. This is a method that we use for determining the density of irregular objects. So let's work it out. Firstly, what is being asked? So we don't miss anything. It's just, I'm doing this so you can follow the way we work out. So what is being asked? We are asked for density, and the unit are even stated. So we have to give it in gram per cubic centimeter. Okay, we give it in gram per cubic centimeter. Okay, can you see? Now this is our question. This is what we need to do. What is density? Density, we can say that the formula for density is equal to the mass divided by the volume. The mass we are given. Okay, now let's look at what is given. We are given the mass, which is equal to 48 grams. Okay, and we are also given the volume. The volume is given in a cylinder. Now we have to work out the volume. Volume we are given, but we have to work it out. So now let's work out the volume. Volume of stone is given by the volume of water plus the volume of the stone, and then from this one we deduct the volume of water alone so that we can get the volume of the stone. So this, if we read it off, it's 33 cubic centimeter minus 25 cubic centimeter, and this gives us 33 minus 25. Okay, this is 8. And then it's 2, and it gives us 8. And it gives us 8 cubic centimeter. Okay, now we find the density. Now our volume that is given here is 8 cubic centimeter. Now we calculate the density. Therefore, the density is given by mass divided by volume, which is 48 grams divided by 8 cubic centimeter, and then this is give us 6 gram per cubic centimeter. Even our units, they have to correspond. This is one way of double checking whether your things are correct. Also, when the unit also corresponds, then it's, you know, you have at least the units correct, if not the other values correct. So we can't leave out the units. Okay, now we move on. Let's move on with pressure. Pressure is given by force divided by area. And here we can see in the diagram a woman in high heels, walking in high heels, and is sinking into the soft ground because the pressure of the heels, the area for the heel is very small, and it gives a higher pressure. While the man walking in boots, you see he's just walking comfortably because the area covered by his boot gives a lower pressure. So that is one example. The higher the pressure, the lower the area, and vice versa. Now we look at the pressure in fluids. Pressure in fluids depends on the depth. You see, the one, if you put, this is a glass or a can of water, and you put puncture in some holes. The one at the bottom, you see, it comes out with higher pressure and lower, much lower pressure at the top, because it depends on the depth. Now we come to the density. Also, this is another example of the density. You can be asked to give a definition for density, and this is one that gives an explanation of the density, which is a mass per unit volume. How much is carried in that area, how many particles are packed in a certain volume or in a certain container. Like here, you see these particles, they are so close together, the first diagram, so they have a higher density. The second diagram, there is some spaces in between, so they are not that tightly packed together, so they have a lower density. So we say density is the amount of matter within a certain volume. That is what we mean by mass per volume. Mass per volume, what is mass? Mass is amount of matter, isn't it? So this is how we define density. And then we go on to the determining of density for regular shapes. For irregular shape, we had an example that we just work out now. And for regular shapes, we use the formula defined by volume, like formula for a cube if the volume is a cube, formula for a cylinder if the thing is contained in the cylinder, and you can work it out. Then you can use those formula. It's quite straightforward. And then we have weight and mass. This is one of the favorite also. For physics, you'll always be asked about weight and mass. Calculate the weight, or you'll be given the weight and you'll be asked to calculate the mass. Or in other questions, it could be hidden in there where you have to know that, okay, I have force and weight is a force, so I can use this to get the mass. And I love this one. They say you are living, you occupy space, so you have mass and you matter. Okay, now we go on. I expect that this stage you should, since you matter, you should be able to calculate the weight and mass. No questions about it. Now we have this force, mass, and acceleration. An object with more mass will require more force to begin its motion and or to stop the motion. This is straightforward. When you are moving something that is very heavy, it's difficult to move because it requires more force. When you are moving something that is very light, it can move very fast. You can move it when you are moving a stone and when you are moving a paper. Which one will take time or will take more effort, more force? It's of course a stone, a heavy stone, and a paper. You can't move it. That's why the two, force and mass, they are directly proportional, and acceleration is indirectly proportional in this equation, the force mass equation. And this is the example. Which of the three? The two. The girl is observing the two boys moving. This one is moving a lighter stone. Of course, we expect that it will move faster with more acceleration. And then the heavier stone, more force, but the acceleration won't be that much. Okay. Now we go to the turning effect of a force, which we call a moment. You'll be asked to define the moment. You'll be asked to calculate the moment. And then you just, is also one of the popular questions where you have to know how to do the calculation for the moment. But the most important to note on this is the principle of moment, where moment on the clockwise is equal to the moment in the anti-clockwise. Okay, then they can be in equilibrium. Here is an example of working out the moment, which is given by the force formula of the moment. Calculating the moment is given by force times the distance. And here you are given the question and the answer is worked out for you. Calculate the moment exerted with a claw hammer if the person exerts a force of 80 Newton and the distance d is equal to 25 centimeter. Okay, but here when you are doing the calculation for moment, careful of your units, because here they have converted. You can say it's Newton centimeter, but the standard unit is Newton meter, so you have to convert your units. Just be careful of your units in that direction. Okay, now we go to the center of mass, or as it's also known, the center of gravity. The center of mass is a body is that point at which the mass of the body may be thought to be concentrated on. Okay, this is what is giving us our stability, the center of mass. Okay, now we have center of mass of symmetrical objects, like that of a circle is right at the center of a circle. Or is that point, the red dot shows where the mass is concentrated of that object, and that is the center of mass. Now we come to finding the center of mass of an irregular object, irregularly shaped object like a card. This card is colored somehow, it has no defined shape. Now how do we calculate this? We suspend and use a plumb line, what we call the plumb line method, where you hang it from different sides. Where the line meets is where the center of mass is. You hang it from one side, you draw a line, hang it from another side, you draw a line, and then you change, you hang it from another side, you draw a line. These lines at some point they have to meet, and when they meet, that is where the point where they meet, that is the center of mass. And this is one experiment that you'll be asked. Maybe you'll be given, you are given this and this and this. Explain how you find the center of mass, and you have to define that method as it's given here. Now the center of mass, we know it helps us with the stability, to have our object stable. As long as it's along the line of the center of mass, that will be stable. If the center of mass is a bit higher or a bit lower, then that causes a problem and is then unstable. Now we go to energy. What is energy? I hope by now you can define energy. Now let's look at the forms of energy. We have different forms of energy. We have potential energy, kinetic energy, as well as all other forms of energy that are given here. Then we have an important concept or a law, that of conservation of energy. That energy just change forms. You don't destroy it, it doesn't disappear, it just changes from one form to another. Okay, now here we have a transfer of energy, where we say it can be transferred from one source to another, like we get our energy from the sun to the earth. Now this transfer of energy, we have three important ways of transferring energy, especially heat energy, which is conduction, convection, and radiation. Conduction, we see in this example, is by direct contact, where this person is touching a hot pan and this heat energy gets to burn the hand of that person. That is conduction. And then we have convection. This is how we get our rain and all other cycles, water cycles, is through this convection, where energy is transferred by the mass motion of molecules. The energy is just moving through the molecules. Only the molecules are the ones transferring energy. So we have here a hot pan that is on a stove. When it's heated here at the bottom, it rises to the top. Then as it's rising, this water, the molecules eventually loses energy in the process. They remain here at the top. They lose energy, then they sink to the bottom. They get heated again. They rise once they get water, once they get the energy, heat energy, then they rise and start losing the energy in the process and then sink again. We call this convection. And then there's also convection current. If there's a movement of molecules where they rise, then they sink, then they rise, then they sink, and then they cause some current waves there, and then we call that convection current. The third method is radiation, whereby energy is just transferred by electromagnetic radiation. It doesn't have to pass through anything. That is how we get our energy from the sun. It doesn't have to pass through anything, doesn't have to be through contact or through carried by molecules, but it still gets transferred. We call that radiation. And then we come talking of electromagnetic radiation. Then we have refraction of light. We have here reflection of light. You have to know this light that are dispersed in their, how they are dispersed and in their colors from as in the order that they are. And you should also be able to draw the light rays for the reflection of light, as well as the reflection. Here I talk of the reflection. When I talk of light, then you should know light is also important. You go to light, but you don't leave out reflection. You don't leave out other important aspects of light. You study light. There's a reason why it was put in here. And then we go to lenses. There are two basic types of lenses: convex and concave. Convex lenses are converging lenses. That means they take light rays and bring them to a point. While concave lenses are diverging. They take the light rays and they spread them outwards. And we use these two types of lenses importantly to correct the defection of the eyesight. Short-sightedness, long-sightedness, and you should know which is which used to correct this. Apart from these lenses, then you should know the focal points, you should know how to draw the focal length and also how to calculate them. All aspects including light, lenses, and also all sorts. Okay, now we go on to electricity. Electricity is a force created by a difference in charges due to either gain or lost electrons. Okay. One important law aspect of electricity, we can't discuss electricity without Ohm's law. And you'll be asked calculations regarding the Ohm's law. And then we go on to circuit diagrams. Okay. Usually we use symbols to draw the circuit diagrams. Like here you see we have a battery here, there is a switch here, there is a lamp. But in our drawing we have to use symbols to denote that this is a lamp, this is a switch, this is a battery. And that when you're asked to draw the circuit diagrams, you should know the symbols correctly, that this symbol represents a bulb, this symbol represents a resistor, and then the calculations also. You see, conductors. Okay, now we have the circuits, simple circuits. Okay, these are the first ones are in series, the second ones are in parallel. I'll give you an example of traffic. When you have cars moving in a traffic, congested traffic, and there's only one lane, those cars will be very, very congested because each car is following the next, waiting for the next one to move and the next one to move. They are congested. That is like the series circuit. But now if you divide the two and you create two paths, some cars are in the first lane, some cars are in the second lane, then the cars will move faster because each lane will be free to move, and then you won't have so many cars congested on one road. Even if they are congested, they will be faster than when they are in one lane. So that's how the parallel circuit is also. When the cars are in two lanes, we say the two lanes are parallel, isn't it? That's the same as a parallel circuit. Take it as an example of a parallel circuit. So these cars will be, at least they are free to move. From one lane they can go, while these ones are still standing. The other one, when the lane is free, they can still go, or they are both can go at the same time. But when they are in one lane, they will be congested. Okay, that is how the movement is also like in the parallel circuit and in the series circuit. Now here we have bulbs arranged in series. This is a straightforward calculations and of the series of the circuits. Okay, and then here, just like an example I gave you, for the lanes, if the cars are in two lanes, they are in parallel. One can move and the others will be standing. The same with the bulbs. One bulb can be fused, but the other one will be working. But if one car is stuck in front of a one lane, then all the other cars will not be moving. The same with the series circuit. If one bulb fuses, then all the other bulbs will not be working. But if it's in the parallel, one fuses, the other bulbs will still light up. Okay, now we go on to nuclear physics. But please do the calculations on the series. Use the Ohm's law and all those formulas to calculate. Work out examples on electricity. This is not all. Now we go on to nuclear physics. We call it atomic physics. We have three types of radiation: radioactive decay. We have the alpha, the beta, and the gamma. And you should know the properties of this. They are basically summarized in this table. The symbols are there, the mass is there, the charge is there. The alpha particles we know is helium particle with a charge of a 2 positive, and the beta particle is that of an electron, and then we have a gamma ray that has no charge, and then we have the speed. Beta rays are fast, but gamma rays are even faster because they are also part of the electromagnetic radiation. They move at the same speed as the speed of light, which means they are very fast. Okay, then we go to the ionizing effects and the penetrating abilities, and you'll be asked also how they can be stopped, how they can be stored safely. Okay, now we go on to calculating the half-life. We can't do the radioactive decay without calculating the half-life. The half-life is the amount of time required for a quantity to fall to halve its value as measured at the beginning of the period of time. Now let's look at this graph. We start at 0. We have an amount of 1.6. the time it takes for this substance 1.6 to half of 1.6 is 0.8. So the amount of time it takes for each to be only half of it left, that is what we call half-life. So that is for it to decay to 0.8, then that is its half-life. And then again from 0.8, for it to have only remaining half of its amount left, half of 0.8 is 0.4. That is still its half-life. That's, you keep on calculating until maybe it's all finished. Okay, here we have an example. It's already worked out. You can go through it nicely and make sure you understand it. Here is some examination advice. This is for all science subjects. Read the questions carefully and fully. Try to understand them, please. Don't just start answering the question without really understanding it. For example, look at the question that says, describe in terms of the movement and energies of water molecules how evaporation takes place. Okay? This says, and it's allocated 2 marks. It shows that you must make 2 valid points so that you can get the 2 marks. You must refer to the movement because it says in terms of movement and energy. So you must refer, the mark goes to the movement, the other mark goes to the energy. So you have to study the questions very carefully and you answer the questions very well. Okay? Make sure you can do your math very well and you are conversant with your calculator. Always show your working so that you can gain marks for your method. Even if you make a mistake with the final answer, you can gain marks for the method, you can get marks for the formula, you can gain marks for the units. So always show your works, including the unit. Avoid vague descriptions. Just because it's something that is close, it doesn't mean you just avoid vague descriptions. Just try to be using the correct terms, the correct physics terms. And at the end of your calculation, when you do your work, go back and see, does this make sense? Is this answer really possible that I can multiply 2 by 10 and get 100? So if it doesn't make sense and you think something is wrong, maybe you can go back and do the sum correction. Okay, and here I gave you some hints on reading the questions. Look at the marks that is allocated. Read the questions. What is given, like the example I gave you, is also hinting on how to answer the question. First, you look at what is being asked. What is it? What information are you given to answer that question? And then you use that information and try to answer that question. If there is a trick somewhere, you'll be able to work it out. Okay? And then answering the question, you should go through some of these hints that I gave you here on how to answer the exam questions, and some of the strategies to beat your exam stress. You should relax. There's no need to be nervous if you study hard enough, but don't try to cram a day or 2 before the examination. The work is for a whole year. The work is for a whole year. How on earth do you think you'll be able to put it in your head in 2 days? It doesn't make sense. So don't try to cram before the exam. Prepare well in advance, and always practice makes perfect. Good luck with your exams. I wish you all the best.